So section 4.2 picks up right where we left off. We decided that this question was not fun to do by graphing. So we're going to try substitution. Step 1. We need to get either x equals or y equals. I'm going to recap and just say, I don't like to use substitution unless this is done. Then I love substitution. Look at this question. We start off with y equals. That is ready for substitution. I can take this negative x plus 3 and I can substitute it. Where? Into the other equation in place of its y. That would be step 2. We are going to substitute the equation into the other equation. So that x plus 3 replaces that y. So it becomes 5x minus, this is wrong, don't put it like this. It's minus the group negative x plus 3 equals negative 27. Okay? We substituted that x plus 3 in place of the y right there. Now what? That's why I put and solve. What's the whole point of this? I now have an equation with one variable. I can distribute and get 5x plus x plus 3 equals negative 27. And I can continue solving. Like terms, 6x plus 3 equals negative 27. Subtract 3. 6x equals negative 30. Divide. And x equals negative 5. Is that what we got last time? X equaled negative 5? No. I misread it a little bit, didn't I? So this is where, like I said, the graphing has its limitations. So going, uh-oh, negative 4, 7 didn't work. It's supposed to be negative 5. Huh. Let's keep going. What do I do with that? That, by the way, was all step 2. What do I do with that negative 5? Well, step 3, we substitute the number into what? Either equation. And solve. So I'm going to put this negative 5, if you don't mind, into that top equation. Y is equal to negative 5 plus 3. Negative 5, y is equal to 5 plus 3, y is equal to 8. Is that our answer? No. That's why we have step 4. Make sure that you write your answer as a point if you want full credit. X comma y. So in this, that was all step 3 right there. So in this, our final answer is x comma y. By the way, did we get that y value right? No, I misread it. It's not 5, 7. It's 5, 8. Is that our solution? Man, I'm pretty sure we could check. I'm going to do that here on the side. If I checked, we just got negative 5, 8. Then that would be y is equal to, let's see, 8 is equal to. Negative 5 would be 5 plus 3. 8 equals 8. But it also must work for the other one. So 5x minus y, 5 times negative 5 would be negative 25. Minus y would be minus 8. Ruh-roh. Did I mess up somewhere? 5x minus y. I'm not sure. I'm going to have to think about this. Because this didn't work, did it? Huh. Give me a second. Negative x plus 3. Ha 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 ha. Oh my gosh. Hopefully you got a good eraser. This is going to happen sometimes. And I could pretend like I did this on purpose. But when I distributed the negative, that 3 was supposed to become a negative 3. So what does that do if that's a negative 3? Well, then this would be a negative 3, which means we wouldn't subtract 3 on both sides. We would add 3. Highlight all my mistakes. That would give me 6x is equal to, how about negative 24? And negative 24 divided by 6 would be negative 4. I actually did read it right, didn't I? Shame on me. So it is negative 4. Let's see if 7 still shows up. Okay? Alright. So we got negative 4. We're going to plug in a negative 4. I'm going to highlight this a different color. Okay? So instead of a negative 5, we're going to plug in a negative 4. Negative 4 makes that a positive 4. And 4 plus 3, y is equal to 7. So our answer is officially negative 4, 7. I shouldn't be so arrogant. So I would check this again. Negative 4, 7. 7 is equal to negative 4. 7 is equal to 7. Now it should work for the other one, right? We said negative 4, 7. So 5 times negative 4 is negative 20. Minus 7 is negative 27. Verify that it works for both. All right. Let's keep going. This one is definitely set up for substitution. I see people that sit there and mess with this and try to graph this, and I definitely don't want to graph this. This would have a y-intercept of 26 over 5. Right? So what are we going to do? Well, step 1 is already done for us. Y is equal to 2x. That's ready. We're going to substitute that 2x where? In place of the y in the other equation. So what does this become? 3x plus 5 times, in place of y we put, equals 26. 3x plus 10x equals 26. 13x equals 26. Therefore, x must equal 2. That's all step 2. Please don't stop at this point. Remember, this is really the reason why we had the first section, was that we understand this is not our solution. This is not a point. You need to, step 3, take that 2 and plug it in. Where? It doesn't matter which one. I'm going to choose the bottom one. Why? Because that is a much easier x to plug in for. In place of that x, we put a 2 so that y equals 4. So we're thinking 2, 4. Step 4, let's check that. Our answer should be 2, 4. Don't forget that you can check it. If I just plug it into the beginning, I get 6 plus 20 is 26. And on the other one, I get 4 is equal to 2 times 2 is 4. Okay. Almost done on this one. This one, see, people freak out and they're like, oh my gosh, I don't have a y equals. Okay, but step 1 is still already done for us. Instead of a y equals, we have a x equals. So what can I do with this? I can substitute this negative 1 minus y in place of the x, because it's what the x equals. So we are substituting that into the other equation. So 2 times x plus 5y equals 7. Substitute and solve makes it negative 2 minus 2y plus 5y equals 7. Combine like terms. 3y equals 7. Add the 2. 3y equals 9. And dividing, y equals 3. Still not done. That's the y value. How do I get the x value? Take either equation. I'm going to take the bottom one. -1 minus y. -1 minus 3, -4. Then last, we write our answer as a point, -4, 3. Why didn't the 3 go first? Because it's x, y. Let's keep going. Another one where I have x equals, right? Step 1 is already done for us. So I can take that 5 minus 2y and substitute that into the other equation for x. So it becomes 2 times x, 5 minus 2y, plus 4y equals 6. Don't forget, all we did was substitute this in here. We have to bring the rest of the equation down. Step 2 is to substitute and solve. 10 minus 4y plus 4y equals 6. Negative 4y plus 4y zeroes out, and I'm left with 10 equals 6. What does this mean, right? How do I solve this? There's no y's left. How are we going to solve this? What the freak do we do here, right? Okay. If you're not sure, we could verify this by graphing. If I took that first equation and I solve for y, x minus 5 is equal to negative 2y. Divide everything by negative 2. I don't feel like graphing this. I could look at it with technology, but I have what? Negative 1/2 x plus 5 halves. Not fun. Second equation. If I solve that for y is equal to negative 2x plus 6. Reducing that, I get negative 1/2 x plus another fraction, 3 halves. I'm hoping you don't have to graph these to see what our solution is. These 2 points have the same slope, different y-intercepts. These two equations are parallel. Which means what? They will have no point in common. They will have no solution. So what does this look like visually? Right? What does this look like algebraically? 10 equals 6. They're not equal. When I get two things that are not equal, like a equals b, 10 equals 6, 0 equals 4, our solution will be that the lines are parallel, or that there is no solution, no point in common. Alright. Next. What I don't like about this example is that step 1 is not done. That's not cool. So we're actually going to have to do that this time. We have to solve for x or y. Pick one. Do I want to solve for this x? Short answer is no. Because if I add the y and have to divide by 3, I don't want to deal with fractions. So if I'm going to have to solve for an x or a y, I would like there to be a 1. A 1y, so or 1y or 1x. I see a 1 right here. Unfortunately, it's negative, but I think that's the best we're going to get. So if I solve this for y, we will subtract the 3x. Negative y is equal to negative 3x plus 4. Dividing by negative 1. Y is equal to positive 3x minus 4. I can use that now. I can substitute. Y equals 3x plus 4. I can put this all in place of the y in the other equation. Okay? Remember, I don't like to use substitution unless the step is already done. We still can, just not as easy as some other methods. Okay? So if I substitute that into the other equation, I get negative 9x plus 3 times, what's y? Equals negative 12. Negative 9x distribute plus 9x minus 12 equals minus 12. Negative 9x plus 9x, those zero out, leaving me with negative 12 equals negative 12. How do I solve for x and y? They all just disappeared. Well, guys, what we do is this. There is no way of solving this. You have to know what this means. A lot of you are yelling at your screen, no solution, no solution, no solution. I'll give you a hint. I'm going to take this other equation, negative 9x plus 3y, and I'm going to solve that for y equals. I would do that by adding 9x and get 3y is equal to 9x minus 12. And then if I divide everything by 3, I get that y is equal to 3x minus 4. What do you notice about these equations? They are the same line. And that means our answer is not no solution, right? They have a solution. Negative 12 equals 12. They're not different like the last one. So what answer would I want for this? This would be infinite solutions. Remember, what would this look like if I graph this? Here would be the first line. Here would be the second line. They're the same line. So what does that mean? They will have infinite points in common. How will they have you do it in the homework? X comma y such that, and then we can write any of the equations. Y equals 3x minus 4. Any point along that line they will have in common. By the way, this is not my favorite method for this. And so what this is going to do is it's going to lead us into our last method, because this was kind of a pain when step 1 wasn't done for us. So when we get past section 4.2, we're going to say, well, maybe substituting isn't always best. Let's agree, substituting is great when we already had an x equals or a y equals. But when it's not done, it kind of is a pain. So that will lead us to our third method, which we've already learned by elimination. And we're going to look at this example and see how much easier it is using elimination. Let's go ahead and jump right into it, because heck, why not? It's right here. So if I look at these two, remember step 1 for elimination is I need to get either x or y to cancel out. How does that happen? They must be the same number, but opposite signs. Currently, all of these are opposite, but they're not the same number. I could make them the same number. For instance, let's take the x's. I got a 3 and I got a 9. I could make the 3 and the 9 both into a 9. Oh, and we do this only through multiplication. Because I'll have some people do this, go, sweet, add 6x. No. That's gonna make a mess all over everything. No, we just need to take this, and to make that a 3 into a 9, we're going to take that whole equation and multiply it times 3. So that 3x times 3 makes that a 9x, that minus y times 3 makes it a minus 3y, that 4 times 3 makes it a 12. That is step 1. These equations are now set up so that the x's will eliminate. Step 2, combine, cancel, and solve. These can combine. Negative 9x plus 9x cancels. 3y minus 3y cancels. And negative 12 plus 12 cancels. Okay, that's weird. What am I left with? Well, when they all cancel, I'm left with nothing. What mathematically stands for nothing? How about 0? On the right side, I'm left with 0. Notice just like before where I had, 12 equal 12, here I get 0 equals 0. Both sides are the same, which means we have the same solution. Infinite solutions. They are the same line. Okay? I will list out the other steps if we had gotten a number here. Those of you that hate substitution, step 3, we have to use it anyway. We still have to substitute. If we had a number that we got here, substitute the number into either equation and solve. And last, once you have both points, make sure that you write your answer as a point, x comma y. Okay. This one we're going to get a solution, so that's good. And I also like this one because guess what? Step 1 is already done for us. What variable already eliminates? We got a negative y, we got a positive y. They are the same number but opposite. So step 2, we can solve this by combining. What is x plus x? What is positive y minus y? And what is 5 plus 3? Don't forget to substitute and or combine, cancel, and solve. So we still have to divide to get that x is equal to 4. Is that our answer? Short answer is no. We have to still take that number and we still have to substitute. So that was step 2. Step 3, it could go into either equation. So x plus y is 5, 4 plus y is 5. If I subtract the 4, y equals 1. If I'd have plugged it into the other one, y should have still equaled 1. Do not forget step 4 to write your answer for full credit as a point, x, comma, y. And we could check this answer. Does 4 plus 1 equal 5? And does 4 minus 1 equal 3? This is the point that these two lines have in common. This is not nice. This I probably wouldn't even use elimination. But I want to, just to kind of reiterate and show you how this works. If I want to use elimination, I need the x's and y's in standard form. So what I need to do is get all the x's and y's on one side. So I'm going to take this y plus 11 and I'm going to move the y over. And get 11 is equal to 2x minus y. That's in standard form. I could think of that as 2x minus y equals 11. Doesn't really matter. Either are fine, but I want that in standard form. Second one, are the x and y's on the same side? No. Minus the y. 5x minus y equals 26. Those are now in standard form. Are they ready to eliminate? Well, line them up. 5x minus y equals 26. 2x minus y equals 11. Those are not ready to cancel. The y's almost are though, right? Look, they're both a negative 1. If we could just make one of them positive, everything would eliminate. How do we do that? Pick one, top or bottom, your choice. Hopefully you said bottom, because that's what I'm going to choose. And to make it change signs, we are just going to multiply that times negative 1. That will change everything. That will make that 2x into a negative 2x. That will make the y into a positive y. That will make the 11 into a negative 11. Okay? All right, I'm running out of space. Let me see. I'm going to cheat a little bit. All right, you shrink up a bit. All right. So where were we at? Negative 2x plus y equals negative 11. What do I need to do to the top equation? Nothing. The y's were already to cancel. So bring it over. 5x minus y equals 26. I just can't catch a break here, right? Let's see. There. Equals 26. That is step 1. Step 1 sucked this time. Okay? This won't always be the easiest way, it's just a way. But now that we have it set up, the y's will cancel and leave us with 3x is equal to 15. Substitute, combine and solve gives us that x equals 5. Please don't think you're done. This is not the answer, is it? You still have to solve for y. We have to plug this into one of the equations. Preferably if I have a y somewhere that's positive. How about 5x is equal to y plus 26? Because 5 times 5, or 25, is equal to y plus 26 is pretty easy to solve. If I subtract the 26, I get that y is equal to -1. What's our answer? Make sure you write your answer as a 0.5, -1. Okay, a few more examples and we're done. This is more like what you would see on the test. I'm not going to try to give you a bunch of crazy ones, but let's agree this still is not ready to eliminate. We need to pick a variable to get rid of, x or y. Doesn't matter. I would hope some of you might choose y, and the reason we might do that is 2 and 3 are smaller than 2 and 5, and it's easier to work with smaller numbers. So you just need to go, okay, 2 and 3 need to cancel. We need to make them both the same number. Couldn't we make them both 6? That would just be the top equation times 2, the bottom equation times 3. Unfortunately, this won't work though. Here's why. A lot of people will do this. Don't forget to multiply the 15 times 2. And the same on the bottom. And then they just cross these out, and that makes me really sad. Because 6 plus 6 is not 0. We forgot that not only do they have to be the same number, but they need to be opposite, which means one of these needs to be negative. So what if we made that 2 a -2? Well, then this would have been a -4x, a -6y, and a +30. What does that do? Well, now our y's are opposite, so they cancel. And this leaves us with 11x equals 33. This was all step 1 up here. This combine and solve is step 2. Dividing by 11. X equals 3. Step 3. What am I going to do with that 3? Substitute and solve. Where? Doesn't matter. Either equation. I'm going to choose the bottom one. Why? Y is smaller. We get 15 plus 2y equals 1. Subtract. 2y is equal to -14. And y is equal to -7. Do not forget step 4. Step 4, write your answer as a 0.3, -7. Almost there. This is not ready to cancel. They're not the same number. So pick one, x or y. I'll do x's this time. Smaller numbers. I got a 2 and a 4. I can make them both a 4. I would just need to make the top one not just a 4, but a negative. Alright, so what's that going to do here? That's going to make that 2x into a -4x, the 4y into a -8y, and that 5 into a -10. The second one I didn't need to change. It was perfect just the way it was. But things start to get weird, right? Our goal was for the x's to cancel. Good news is -4 and +4 cancel. What's a little weird is to also do the y's, right? So what are we left with on the left side? What does this mean? Same thing it did before, right? If they're not equal, then that means if I were to graph these lines would be parallel. They would have horrible y-intercepts. But if I graphed the first one, it would be y is equal to negative 1/2 x plus 5/4. If I graphed the second one, it would be negative 1/2 x minus 9/8. But the lines would be parallel. So we would have no solution. We would have a contradiction. Negative 1/2 plus 5/4. Let's see. Negative 1/2 x plus, I think it was 5/4. And negative 1/2 x minus 9/8. Negative 1/2 x minus 9/8. When are these lines going to cross? They never get any closer, any further apart. They have no solution because they are parallel lines. Okay, last couple, just to recap a couple things. This is not set up yet for elimination, and so we freak out and go, oh, it's so horrible. Okay, what makes this question hard? Well, it's got fractions, right? Could we clean that up? So it's not really in that ax plus by equals c where all these are whole numbers. So what if I just took that bottom equation and I multiplied it by its LCD, just like we did before? The only thing making this a fraction is this dividing by 2. So what if I multiplied everything times 2? Well, 2x would become 4x. 3/2 times 2 just becomes 3y equal to 12 times 2, 24. The other equation was 4x plus 3y equal 10. Don't start crossing stuff out. These are not canceling yet. What do we need to do? Well, one of them needs to become negative. I don't care which. Maybe we could have used that as a negative 2. I'm just going to take the bottom equation and multiply it times the negative 1, so that when I bring it down, that makes the 4x negative, the 3y negative, and the 10 negative. Now we can start zeroing stuff out. Cancel, cancel, 0 equals 14. No, it doesn't. This is also no solution. When they're not equal, no solution. Okay? When it's a fraction, clear it using multiplication. I probably wouldn't test you with this, but it definitely could show up in the homework. It could show up in word questions, so get yourself prepared. Last but not least, this could show up. Do decimals show up in real life? Absolutely. What do? Right? Go home and cry. No, let's figure this out, right? What can we do if I don't like decimals? Well, I could multiply everything times 10 and move the decimal over. What would this become? Well, 5x plus 24y, not loving that, equals 42. This same one times 10 would give us negative x, or negative 1x if you'd prefer, plus 15y equals 51. Still not loving it. But I could now solve this and not worry about those decimals, so don't let that freak you out. We need either the x's or y's to cancel. Out of these two, I'm definitely liking the x's. They're smaller of the two, right? So I will take the bottom equation, and all I really need to do is take that bottom one and multiply it times 5. To make that negative 5x plus, 50 and 25, how about 75y equals 51. 5x plus 24y equals 42. The x's, that's all step 1, because now the x's will cancel. 99y is equal to 93. So we got 93 over 99. Is it wrong? I don't know. Let's double check our work real quick. So let's see. 5, 24, 42, liking that. -1, 15, 51, liking that. Ah, I forgot to multiply the 51 times 5. Shame on me. This 51 times 5 should have made that. How about 225? Hopefully some of you are screaming at your screen. 225 plus 42 would be 267. And that divided by 99 still doesn't look fun. 267 over 99. Let me see. 267 over 99. Oh, that is not fun. Is it right? Let's double check. I did all this times 5. -5, 75, 220, 255. Quit trying to do mental math. 51 times 5 is 255. 255 plus 42 would be 297. 297 divided by 99. I like that a lot better. Y equals 3. What do I do with that 3? Plug it in. Where? Either one. I'm wanting to solve for x. I could choose the bottom one since it's a 1x. I think I'm going to choose the top one just because I like the x that is positive. What's y? So 5x plus 72 equals 42. Solving that, 5x equals -30, and x equals -6. So, our solution, that was 1, let's see, 2, this was step 3, step 4, write your answer as -6, 3. Interesting. Is it right? Now I could plug it in. What I'm curious about is, yeah, why don't we do that? So -6, 3. I'm going to plug it into the original equations. 0.5 times x. So 0.5 times x, which was -6. Plus 2.4 times y, 2.4 times 3, and I believe this was supposed to equal what? Is it 4.2? 4.2? 0.5 times x. Double check, make sure I'm not crazy. Let's see. Is that 4.2? Interesting. The second equation, -0.1 times x. So -0.1 times x, -6. I should put some parentheses in there. So -0.1 times -6 plus 1.5 times y. Y was 3. Is it supposed to be 5.1? Says it's going to be 5.1. This is our solution. And you can check them. This is it for really a huge chunk of Chapter 4. So hopefully you got that down, and we will be building on this very soon.